Hello and welcome to GigaOm Live. I am your host, Johnny Baldisberg, and today I am joined by analyst Enrico Signoretti and Jason. Oh no! No, Enrico is off somewhere. You know what? For the
Yeah,
life of me, I can't remember
he's
what he
slumming
said.
it in Tuscany, right?
I assume, I assume he's kite surfing. Frankly, for those of you who only know Enrico from his incredible intellect and writing about data storage, whenever we talk to Enrico, he regales us of tales of kite surfing and doing like 40 feet leaps in the air. It's amazing. No, today it's just me and Jason, which means that I'm going to be bombarded with financial news and the ins and outs of bulls and bears, and I am just not ready. Um,
You're
it's
lucky.
also
You're lucky, Johnny. I'm not going to bombard you with a lot of news on finance today.
and because I don't know if watcher, I'm used to doing podcasts and calling everyone listeners. Watchers, I don't know if you've noticed, Enrico is always dressed really nicely, and it's forced me to at least throw on a polo. But since it's just me and Jason today, I decided I would represent Studio Woe, a local Austin game company. Since you're not wearing an Atari shirt today, I figured someone
I'm
had to
not.
be a nerd, and it's me. It's me this time.
There you go. Well, I got it's a cool shirt though. It's like an Austin shirt instead of an Atari shirt, and yeah, we got space, we got guitars, we got all kinds of just Austin weirdness going on. So
You know, if we had thought about this earlier, we could have done this in person. We both live in Austin. It'd be the
true.
first GigaOm live show where we're on stage in front of
We go live.
GigaOm Live. So this is a show where we discuss the tech news of the last week, and you know, this week in particular, it's going to be me more asking questions of Jason, who is the expert here. I'm just the curious mind. This is a live show, though, so if you have questions, if you want to comment or say anything at all, you can hop into the chat either on Twitch or on YouTube and chat at us, and I'll relay those questions back to Jason. Otherwise, we're just going to kind of leap into what we have today. And I'm actually really excited about this topic. I joined GigaOm because of its connection to AI. We did a lot of AI back in the day when I first joined, and obviously we still discuss AI and ML, very important parts of the tech industry. But America to get world's most powerful AI computer to create the most detailed 3D map of the universe. That's so cool. What is this?
It is. So this was actually an article that was put up on the register, and yeah, the cool thing is they're utilizing a lot of this new technology. So there are, I think it's going to be done in two phases. The first phase, so HP is putting together and assembling this infrastructure. The first phase is going to be like 1,536 compute nodes, each containing four of basically these NVLink, the NVIDIA A100 TensorFlow chips. Let's just say those things they got a lot of juice. By the time I think phase one is done, I don't know if this is like the full phase one or phase two, it'll be 4 exaflops worth of processing power from an AI perspective. So
Now hold on, Jason.
yeah.
That's a new term for me. What is an exaflop?
So an exaflop is bigger than a petaflop, right? And a petaflop is so one of the things that I was looking at, like I think a standard single node of what you can get from those A100 NVIDIA TensorFlow chips. They sell this workstation where you can get 4 of those in there, and it can do, I believe, 5 petaflops. Now, to put this into perspective, I built a supercomputer back in 2005. We ranked it on the top 500 supercomputers at the time. It could do 1 teraflop of capacity in 2005, and it was ranked number 70 on the top 500 list. And that's the top 500 fastest supercomputers on the planet, right? So it could do 1 teraflop. Now you've got this one machine that can do 5 petaflops, which is 5,000 teraflops. And this, by the way, took up like a room, right? It was like 400.
Okay,
I think there
but
were
to
like
be fair,
800 CPUs in it.
you built that out of like scrap and blenders, essentially.
It was awesome though. I mean, we built it for $65,000, and when we benchmarked it, it was faster than BMW's crash test supercomputer they bought from IBM for 10 million. So,
Good God.
so it was pretty cool. But yeah, I mean, just like at 4 exaflops, I mean, like an exaflop is like 1,000 petaflops.
Right.
So it's like you're talking about it's a lot, right?
Yeah.
And here's the thing: they think it's probably going to be in the top 5 of the top 500. So this is, even though it is like, this is awesome, it's going to be super fast, it's still not the fastest.
Wow.
And the application of it though is pretty cool. This is, I think, the most amount of GPU compute that's put into this specific thing. And I tell you, if anyone's really interested in this AI topic as well, Stephen Foskett and our buddies over at Tech Field Day are doing the AI Field Day. Day 1 was yesterday, and day 2 is today. It starts at 8 a.m. Pacific time. We're here in Central. It's like at 10 o'clock. So I'm going to be tuning into it after this.
And we have various GigaOm analysts that are participating. Andy Tarai, Chris Grundeman were both part of that. So it's going to be fascinating, and obviously GigaOm is right in the thick of it. Going back to AI for just a second, for those of you who are maybe less versed in how AI works, in this supercomputer, I just want to make sure I'm not talking out my butt here, Jason. Correct me if I'm wrong or lying or anything like that. What this AI is doing is collating incredibly massive amounts of data and working with algorithms that will deal with mathematics, physics, astrophysics, obviously, to build this 3D map. And obviously, this is the thing that people used to have to do by hand to find things, and now this supercomputer is going to be able to take, what 1 million people would do by hand, years ago, and condense it into one program, essentially.
Right.
It's really, I'm nerding out over it because I'm so very excited.
Yeah, and really, I mean, what they're doing, and then by reconstructing this, they're actually taking all of these telescope data points. They say it's something like about 150,000 data points are going to be generating every night, and they're mapping the some like 30 million known galaxies. And putting that all together in this just giant 3-dimensional reconstruction of what the universe looks like. So yeah, it's just the sheer amounts of data that when you're generating, and then you have to do the processing on it. Another thing that NVIDIA is working on that they announced was the Grace CPU. So NVIDIA is talking about buying ARM. They basically announced that they were going to do that, and everybody thought, oh, they're going to get into the CPU industry. Reality is, what they're really doing is processing that much data. Getting that much data moved into the GPUs is now the bottleneck, right?
Wow.
So there's not a CPU, and right now a lot of what they're doing, they're using AMD's EPYC chip to get stuff in there, but specifically they're working on this Grace CPU. That its entire purpose is not general purpose compute. It's to basically get data in parallel, like into those GPUs as absolutely as fast as possible to get basically the data in and out, and then that's where, too bad Enrico's not here, because one of the companies on Tech Field Day was Scality. And Scality's been, they've had a object stores for quite some time. They actually started about the same time I started, like my last company as well. Great guys. I know the CEO and a lot of the founding crew over there, and talk about a great group of folks. But they've been doing object storage for a long time. And I know they've got basically several, not necessarily as focused on like the HPC ingest, but they've been doing a lot with like Splunk and things like that, where they're kind of the ingest engine for a lot of that. But it's also, about processing all of this big data, and they've got some really cool tech around how they do that with their ring. And then they're also working on pushing that out to the edge with their ARTESCA. And they actually partnered with HP, who's building this supercomputer. They're partnered up with HP offering this ARTESCA out at the edge. And when you think about this too, from a high performance compute, you always think about big supercomputer in a big room. But the reality is we're collecting so much data that they're moving a lot of the processing out to where the data is collected, like at the telescopes.
Wow.
One of the interesting things from SETI, used to, the SETI at home, they'd be using like all the compute power from everybody's, desktops and doing the screensavers. But what they found, the data movement was the biggest issue. So now they've actually there's literally ARM chips on all those radio telescopes, and they're doing as much of that pre-processing literally at the telescope. So there's like these big 5,000 arrays of telescopes all over the place where they're actually doing the processing for the SETI stuff directly on the scope itself.
So we have a question from YouTube.
Yeah.
Specifically, they want to know what you needed a supercomputer for. They're curious if you had plans for world domination that didn't come off. If you're trying to do a hostile takeover of the market, maybe. But if I remember correctly, you did this just to prove you could.
Partially. Interestingly enough, so actually, one of my patents that has my name on it is in AI. So we built a neural network classification engine that we use to do basically detection of spam messages, right? It effectively would read a message and then determine the intent by feeding it into like basically trying to remember how big, I think it was like a 5,000 input node neural network. And then it would determine whether or not, the email was junk, bulk, or legit. So we did that company. It was around for 2 years. We sold it. And then we thought, well, this is pretty cool tech. What else could we apply, basically a 3 disposition neural net to? And then we're like, oh, buy, sell, hold. So we built the supercomputer to analyze the stock market and make stock market predictions. It actually worked pretty well. The thing is, we built the supercomputer. We got into the hedge fund business and realized we're not hedge fund guys. We don't really like the business, but building a supercomputer is fun. It was cool, and then that's kind of how we started our third venture-backed company that we did, which evolved into scale computing. So, We loved the science project, and then realized that we were not cut out to be Wall Street hedge fund guys. So.
It's amazing how often that story has been told. People say, oh, I got into this because I did this, and I hated that, but the method that I used to get there was a ton of fun, so now that's what I do.
Yeah.
Case in point, I never meant to write scary stories. I wrote,
and here you go. Now you're a famous horror author.
I was gonna say, and then I wrote. I was like, "Hey, what do you think of this?" And everyone kept being like, "This is terrifying." Like, oh, well, I guess I'll lean into that then.
Yeah.
But speaking of hedge funds and things I'm not good at, we do have some financial news.
We do.
Dell, Intap, Box, CRM, HPQ. You've just written numbers here. I don't know what any of this means.
So Dell, NetApp, Box, Salesforce, and HP, the consumer division, the guys, the laptop side of things, okay. Not necessarily the enterprise side. Everybody, all those folks this week announced earnings. The good news is they pretty much all exceeded expectations. Everybody met or beat what the street thought they were going to do. Now, the funny thing is, I was telling you kind of before we went live on this, and what always cracks me up is, so then the analysts like went ahead and they raised expectations. They're right. Like, oh, they're going to hit this price. And then I think every single one of those guys is like trading lower today after announcing, like, look, we beat what everything, what everybody thought we were going to do. We're better than that. And then, then the stock goes down. Investor sentiment, but a lot of that stuff is kind of pre-baked into how Wall Street's going to think they do. And really what, quote, beating the street is a number that, it's already pre-baked. Nobody believes the street number anyway. So.
I already have a headache from trying to understand any of what just happened. here, and to hear that like everyone says, "Oh yeah, this is definitely going to do well," and then it does lower, is terrifying. Luckily, I invested everything in Dogecoin, and
There
I'm
you
just going to just to prove how well that went. Let me check. Oh no,
go.
oh no. Um,
Cryptos are fun.
well, I'm destitute now, so let's move on to the next bit. Now,
Yeah.
yesterday we heard from Scality and Liquid.
Yeah.
Uh,
Liquid is another.
yeah.
Liquid is a really cool company. And where HPC is going, Liquid's going to be a fundamental part of that. Actually, Submit their CEO and I think yeah, he was talking, and I believe the number is about 80% of the deals that Liquid is working are in HPC as well. Now, what Liquid does, it's it's a term that's been used quite a bit, but it's also not really defined very well. But it's composable infrastructure,
Okay.
and what Liquid is, and Smith, their CEO, also said this, and I'm just like, this is the perfect explanation for what it is they do. What VMware did for a computer, it lets you virtualize all of the components of inside a computer and create a virtual machine, so you can divvy up how many compute resources, how many memory resources, storage resources that you need for a virtual machine. Liquid is like that, but for the actual physical infrastructure itself. So Liquid can take, so let's say you've got, so they've got a core component of what they do is a PCI switching environment. And I believe it's like kind of primarily Broadcom chipset, where here is a PCIe switch. So just like an Ethernet switch, here's a switch for a bunch of PCI cards. So you could have a machine that's just like loaded with GPUs, like just a bunch of PCI slots with like 20 GPUs in it, or storage devices, or like FPGAs, whatever it happens to be. And then you can dynamically carve up, like, say, I want this CPU. Let's say I'm going to run this math calculation, and it does really well with GPUs. So I can take this one single server that could actually happen to be like a 1U server with dual CPUs, and then assign 20 GPUs to it dynamically. So it lets you take the physical components of your infrastructure and then like recreate a machine out of all of the disparate parts. So from a cool factor perspective, I mean, it's some pretty sweet stuff, and it's going to be, there's a lot of application for that in HPC, and there's a lot of application for it, in enterprise as well. But I can see why they're doing really well in HPC, because say you've got this math problem you need to calculate, and there are efficient ways of doing it, but you may not necessarily have all those resources inside that specific machine. That lets you kind of dynamically reconfigure what resources are available to it. So it's definitely. Like that is going to change the way data centers are built from a composability perspective. It's really cool tech.
I'm going to channel a show we used to have on GigaOm called Voices in AI, and I'm going to ask you this: what makes artificial intelligence intelligent, and what makes it artificial, and why? What is the major roadblock that like people are addressing at things like Tech Field Day? Are they creating use cases, or are they trying to figure out how to push it forward? Is it everything? What's going on in AI right now?
Yeah, I mean, it's a little bit of everything, and there's a lot of different ways to define it. You've got basically the quote machine learning, AI. Typically, a lot of the inferencing stuff that is being talked about is related to the neural network.
Okay.
An interesting thing about, and just I know mostly about the neural network based on kind of my history in the past, but one of the everybody's got this assumption that AI is going to fix everything, right?
Right. Yeah.
One of the
Magic bullet, as John Collins would say.
One of the very interesting applications of this, and Google published a paper like a couple years back about how they utilize neural nets and AI to analyze their data center, and it saved them 30% cooling costs by figuring out different ways to remap things, right? and when to run certain hardware, when to shut it off because it was like less of a demand utilization time period, right? So they could actually dynamically turn things on and off and basically get better better power consumption. So then everybody's just like, oh, well, I want that for my data center, right? Well, here's the thing. You don't just go and buy a piece of off-the-shelf software and do it. You know why it is, but I mean, you just sit there, you train a neural net, you test it, you're like, oh, well, this one sucks. Train another one, train another, and train another one, right? So it was, one of those things where you had to really just go in, train it, inference it. It would get better. But the whole component about it is it. You need to teach it on a specific set, but you got to test it on a very other specific subset. So the reason that Google was able to pull it off is, one, they got a lot of smart people, but they also got a lot of data, right? So they could feed the engine a lot of data and utilize the compute power to figure out, what is the build the best neural net to figure out the problem, right? And so there's a lot to it. And like I said, the reason that they were successful at pulling it off is they've got a lot of smart people and they got a lot of resources to do it, right? But it's
Absolutely.
not just something somebody can assume that I just buy this AI thing, I stick it in and it makes everything better. It's kind of not how it works.
Well, yeah, we've been huge proponents of figuring out your own solution here at GigaOm and not realizing that very rarely is the boxed item the thing that you need. But, or rather, let me rephrase that. Buying the first cheapest box or the most expensive box you see is not always what you need. However, if you have Google money,
yeah. That's kind of like they encourage that. They've also got the that's really kind of their whole workplace. Their flow. The mentality is like, go off, work on these cool projects, and then if it turns into something really cool, then we'll put effort and money behind it, right?
Yeah, absolutely. So last week we had a company all hands meeting. Your old friend Ben Book is our CEO, and he kind of led the charge. The very first all hands meeting I came to at GigaOm had 5 people on the call. Last week we had over 50, and the lion's share of that were analysts. Brilliant analysts. It's a little intimidating for, my Luddite butt to be in there amongst these giants of technology. But it's always really amazing to see these people. I have another window open, and the head of research and development, Mike Desmond, just pinged me like, Ben wants this right away. It's like, well, so things are picking up speed, which seems impossible because we go so fast to bring out this incredible research. Across the bottom, underneath me, I'm gesturing to it right now, we have some of our featured research showing the GigaOm radar for vulnerability management, medical automation, AI for the OR, and work from home security, which are 3 reports we had come out fairly recently. Now, we did cancel the webinar that we had last week, which was with EQualm. EQualm is located in Israel. So due to the ceasefire and the conditions over there, we decided to hold off on that. That has been rescheduled for June 16th, I want to say. Yeah, June 16th. So next month we have 2 webinars already on the books. EQualm on June 16th and Cloudera, which is machine learning. More AI. Production grade and industry strength. So it's going to be a really fascinating month. We have so many reports that I am working on right now. Like I said, my boss, Mike Desmond, just messaged me to tell me to get on it. So we have a lot of reports coming out next week. This segment where I talk about the research is going to be like half the show next week. Not really. We'll talk news, I promise. But it's going to be great. That is all the time we have for today. So, Jason, I want to thank you for joining me today and allowing me to have this big corner of the screen where Enrico usually is. It's very flattering.
Yeah, you're bigger than normal this week.
I know, it's kind of terrifying. I am very handsome, so it's okay.
Yeah, that's all right.
So, and thank you all for watching us talk about tech and my terrible jokes. We appreciate that. Jason, you can be found on Twitter at Bocanuts. Enrico's not with us, but if you wanted to follow him, he's at eSignoretti. I'm not going to share my Twitter handle because I just talk about scary books. But you can find us on Twitter at GigaOm. So if you want to follow anyone, follow GigaOm. You can also find us at gigaom.com, where you can read our blog, sign up for webinars. You can listen to the Voices in Innovation podcast. You can also subscribe to our full breadth of research and see all the incredible things we're doing. Get your advice for your industry. You can also talk to our sales team if you want to commission research and you need to talk to an analyst to get even more in depth. You can do that from there. So for all your future forward advice, gigaom.com really has you covered. Jason, thank you once again.
Thanks, Johnny. Appreciate it as always.
And thank you all. Have a great weekend. For Enrique.